Hi everyone, my name is Dave Flynn. This is my MIS 653-50 presentation on manufacturing execution systems. Thanks for watching. I want to start with a simple definition. This one comes from Wikipedia, and it's sufficient for this introduction to the concept. A manufacturing execution system is a computerized system used to track and document the transformation of raw materials to finished goods. The genesis of these systems can be traced back to traditional factory or shop floor operations, in which we're really talking about taking in raw goods like steel and producing finished products, but they're used in a wide variety of modern businesses to solve the same kind of problem. MES software is intended to fit into the niche between the ERP, or Enterprise Resource Planning System, and the command and control systems like SCADA that actually drive machines and factory processes on the floor. We'll get into more detail about those elements of the operation shortly, but I want to start by defining the problems that MES is trying to solve. In general, the core goal of any manufacturing operation is to increase efficiency and reduce waste, both of time and materials. Historically, the goal tended to be throughput, producing more goods per unit time, whereas modern businesses are often focused more on cost containment and financial efficiency. In either case, any factory wants to avoid excess inventory that's not being converted into saleable goods. Inventory represents a capital expense, and the longer it sits on a shelf in a form that can't be monetized, the more of a company's resources it consumes. Bottlenecks on the factory floor are deadly. Resolving bottlenecks in a manufacturing operation isn't really in scope for what we're talking about here, but it's an important part of visibility into a factory operation. Eli Goldratt wrote a book called The Goal, which introduces this concept he calls the theory of constraints, which digs into how bottlenecks emerge in a factory and how to find and fix them. And finally, almost all businesses rely on forecasting to drive their operations, but forecasting is never perfect. One of the essential functions of an MES is to give executives and decision makers the ability to analyze manufacturing operations in real time to make good decisions about where and how to invest resources, increase or decrease lead times at the sales level, and so on. The data from an MES also helps to pinpoint problems or weaknesses within the manufacturing operation that should be fixed to improve the overall position of the business. I want to talk just a little about different types of manufacturing represented by the different Level 2 SCORE process definitions. There are three broad categories. Make to stock implies the production of a finished good according to forecasts of demand. In effect, the business produces an amount of a finished good that it expects to sell, even if it does not yet have orders for all of the product it makes. Make to stock products require reliable forecasting in order to avoid over or underproducing. MES data can help drive these decisions and adjust quotas in real time, although in practice, much of the forecasting work is done in the ERP and not the MES. Make-to-order processes are executed in response to a sales order rather than against a forecast. In general, the implication is that the business produces the relevant good on demand rather than maintaining a stock of completed products. MES in this context provides valuable information about the process of a production order, which can be used to provide feedback to customers about the status of their order, particularly if there is a problem on the shop floor that causes delays. And finally, engineer-to-order processes are often the most complex and represent custom products built according to a customer's specifications. By definition, there must be regular bidirectional feedback with the customer throughout the design and manufacturing phases in order to ensure that the product meets the customer's requirements. MES systems can make the process of change management easier to handle, particularly in terms of providing good information on how a change will impact the production schedule or cost of a project. And similar to make-to-order, it can also provide good data to customers about the status of their project and the expected date of completion. So just a little bit of history. Back in the late 80s and early 90s, as computers really started to become integrated with the business, a new type of computer system called the ERP was engineered. The idea was that the ERP would be the one-stop shop for all business operations within a company. In practice, ERPs are still and were then enormously complicated and difficult to manage, and they weren't good at providing real-time analytics of operations on the factory floor, which are analytics that executives need to have to make good decisions about the factory operation. ERPs were good at financial planning, they're good at interacting with customers, taking sales orders, and so on, and they're good at making payroll happen. But something a little more focused on the manufacturing operation specifically was needed, and that's where the MES comes in. It's not there to make macro-level financial decisions, that's not there to interact directly with factory equipment, but it sits between those two systems in order to arbitrate and provide data on decisions that are necessary to make the manufacturing operation itself more efficient and sustainable. This slide is just a bit of additional background. In addition to the ERP, which we can think of as the high-level financial and customer management system, most modern factories rely heavily on computer-based automation to actually manage the equipment on the floor, which includes everything from directly issuing commands to specific machines like a heat press or a lathe, to specifying the inputs required for the next job to be run, and so forth. The general term for this type of software system is SCADA, which stands for Supervisory Control and Data Acquisition. And I mention it here purely to add some context to the role of the MES. The MES doesn't explicitly control factory equipment, nor is it responsible for long-term financial planning or accepting sales orders. It's the system that sits between those two broad categories of computer software to arbitrate and provide real-time information back and forth. The term MES was originally defined by the Manufacturing Enterprise Systems Association as a dynamic information system that drives effective execution of manufacturing operations. But in practice, this doesn't necessarily provide a clear picture of what these systems really do. All manufacturing execution systems are used to manage and monitor work in progress on the factory floor in some way, but the specific software functions often vary widely by industry. In general, though, we can say that MES systems allow users to specify when materials should be ordered, to schedule tasks against an organization's production capacity, to provide visual or data-driven representations of production workloads in real time, and to offer some form of overall measure of equipment effectiveness to gauge efficiency. Some MES systems can also guide workers or machines through the production process directly. This is just a simple graphic to help illustrate the position of MES within the overall software portfolio. The ERP sits at the top and is responsible for strategic forecasts, financial planning, and customer interactions. And the plant management systems like SCADA sit at the bottom and interact directly with machines and personnel. The MES is a specialized system that works in the middle to coordinate interactions between these two systems and provide visibility analytics to the executives and the operators of those machines. In the context of a make-to-order process, SCORE defines 6 Level 3 subprocesses as written here. The MES is often responsible in some way for all of these, but is particularly essential for the first 3 given its role as an analytic and control tool for the work that happens on the factory floor. The MES coordinates the release of raw materials onto the factory floor and the scheduling of any machines required to convert those materials into a finished product. It often manages the QA process and can also be used to oversee packaging, shipping, and delivery, although those latter functions are commonly handled by other systems. In essence, we can think of the MES as taking over from the point that a sales order is generated to the point that the order has been delivered to the customer. The ERP is responsible for the rest. In addition to the things that we've already talked about around efficiency and problem resolution and data visibility, one particularly useful feature of an MES has to do with the reduced cost of regulatory compliance in industries where detailed information on the manufacturing process is required by law. And a good example is the food service industry, where in the United States, FDA regulations specify strict handling requirements for food products throughout the factory process. And an MES, properly configured, can provide all of that information and export it easily, which simplifies the process of responding to regulatory requests and new requirements. Thanks for taking the time to watch this presentation. I appreciate it. There are some questions a few slides later, and I encourage you to post any additional questions or comments you may have in the discussion forum provided. Thanks again. Take care.